about now? How about now? Do we have some audio?
Hello, hello. Do you have any on the iPad?
I don't know. I can't tell how far ahead we
Mm,
are. Oh,
hello.
yeah. Yeah.
What?
We have audio.
We do?
Yeah.
You sure?
Positive.
Okay. Oh!
All right, I got
Yes,
those
and
then.
just got confirmation from Douglas. Okay.
Excellent. Thank you for your patience, Doug.
Oh my God.
I'm so tired.
Oh,
I hate this thing.
good Lord.
Okay, I'm going back
That
to
was
Pony.
that was long.
That was painful. It wasn't as long as last time though. Last time was like 6 hours, right?
Now you're just now your hyperbole is just like it's diminishing how long
Yeah.
it was.
It was long though. 38 minutes.
Very
Painful.
long.
So
Okay.
for the future, I needed to make some scene somewhere live, and I didn't realize that because I'm
Mm.
not the brightest guy on the planet, apparently. That's what happens when you get old. Okay.
So I think the best thing to do is we covered a lot of stuff last time, but I don't know how much would stick, right? So maybe if you go to here, let me send you this link in the chat, right? I'll send you the link in the chat um, for the workshop and step one, and let's just
Oh,
let's take a look and let's see if there's anything that we need to review.
I've got the
Right.
workshop right in here.
Yeah. I don't think you would. It's the README for step one, right?
That thing?
Well, I'm not looking at the live stream, so
You
hold
don't
on.
need to look
Wait.
at the live screen, just look at the
Oh,
screen. I can make you follow me
what screen?
on oh, what do you call it? Here, there,
Okay.
that.
Yes, that. Yes, there we go. So we have that. So yeah, it starts from the simple hello world which we were playing around with before. You remember the compiling with just like Pony C, right, in the program. Okay, that's good. Um, Uh, so you remember actors and the main actor, right? From the capital M and the messaging. It's all good. The aliasing, we covered that a lot. You feeling good with the aliasing with variables and whatnot?
Yep.
And let's see, what else do we have here? Yep. So I think we're good for one. Let's go to two and see how step two. Okay. So we didn't really cover this. I think we should. I think this would be a good one to start with, in some of the stuff that's going on here. So why don't you go ahead and open up the? There should be some code that goes along with it that's not in the README,
Got it.
right? The main.me that's there. All
Okay.
right. So yeah, I mean this it's a pretty simple program. If you compile it, right, it's going to print like hello world or whatever it is that you pass for an argument for it, right? And yeah, it's using the args from env. This is a really this is a really simple one for what it's doing. Go ahead, compile it, and just give it a try.
Okay. It works.
Right? Yeah. Where did you? Oh,
I
there
have
we go.
I
Okay.
have the terminal and VS Code open.
Yep. Yeah, I was looking at the wrong window. All right. So, did we talk about recover blocks before? I don't think we did.
I think we did briefly, but we should go over them again because I'm old and things need to be drilled
Okay.
in.
All right. Well, before we get to the recover blocks, then, do you remember the different reference capability stuff?
Yeah.
All right. Okay. So now the let's talk about the we cover those behaviors, um, and we also we covered the partial function, right? So partial functions. Did we cover that? This line right here that I'm highlighting? E and V
Why
are
is that a
supply.
partial function?
I don't think we did. Do you see the question mark at the end?
Yeah.
Okay, that means it's a partial function, right? So I don't think we covered this. So a partial function is a function that for some set of inputs might not be able to return a result. Okay?
Okay.
Does that make sense?
Yep.
So it's wrapped in a try else end block here, which makes it look. Oh, I have a cat that's harassing me. Hold on, I need to give some treats. So it makes it look like what's happening there is like an exception from another language, right? But there aren't actually any exceptions in Pony. There's you merely have something that's called an error. But for the meantime, just go ahead and think of it as being like an exception. But there are some important differences that we can get to later, right?
Okay.
But so anything which can generate error, and there's an error keyword, has to be denoted at the call site with this question mark. If we go ahead and remove that question mark and then try compiling it, right? Pony C, we will get an error, right? Let's see. Can I?
Method
Is
is here. Stuff happened. Bad things.
Yeah, it's right. I'm having a hard time getting the message on.
It's okay.
I unfortunately, I'm at least when it gets to me on this side, I'm missing part of the error message for some reason with the terminal output.
And that's because of tmux. Let me remove that. Okay.
There we go. All right. Okay. So call is not partial, but the method is question mark is required after its call. Right. So if we put the question mark back, you'll be able to compile it. So the reason for this is in most languages when you have exceptions, right? Exceptions have a type, right? You know, like this is a null pointer exception. This is I don't know. Pick whatever your favorite exception is. There are no types for errors in Pony, right? Which means that for any try else that you see, it's not like you're going to have try and then catch this error or that error or whatever. It's just an else in order to handle the fact that some block of code was not able to compute a result, right?
Okay.
Now, it would be very nice if we had potentially more than one thing within this block of code, which is partial, right? Or even just we had 5 lines of code to be able to know which one is partial, right? Or which ones are partial. And so there is a requirement at the call site when you're using a partial function to have the question mark at the end so that you can know when you're looking at the code right there, this one can generate some type of error, right? A error could be generated from this, and in my else, I'm going to need to handle this particular error. This also means, for example, if I had like 3 additional lines of code in here, right, and one of those functions became partial later on down the road, right, didn't used to have an error, but now it has an error, then this means it will become a compile error until I put the question mark there, which also gives me a chance to adjust my possible error handling strategy because something that was not previously partial is now partial. Make sense?
Mm-hmm.
Okay. Now,
It's interesting that the function type is called partial, and it sounds like it's an adjective, not a noun. It's
So
partial
in,
function.
a partial function is there's actually a partial function is a term that comes from mathematics, right? So, for example, division in mathematics is a partial function, right? There are some inputs for division for which you cannot compute a result. For example, dividing by 0,
Okay, that makes
right?
sense.
Right? It is partial for the complete range of inputs across, say, integers, right? Division is not able to compute a result for all possible inputs. Therefore, it's partial. Right?
I'm with you.
Okay.
So how do we
So
denote, let's say we were writing our own function.
our function, yes. Let's go ahead and
How
add
do
it.
we make
Let's
one
go
that's
ahead.
partial?
Okay. Well, let's go ahead and we'll add a function. All right. Okay. So fun foo. Oh no. Let's go for the best Sean name. Right.
Yeah.
So this is going to be this question mark right here,
Mm-hmm.
which comes at the end, means that it's partial. So we could have something like this, right? Where let's do this. 64, right? If n is greater than 10, then else. All right. So did I typo anything? No, good, I didn't. So there we have free candy is a partial function, right?
Okay.
There will be an error if the value of n that we pass to it is greater than 10. Otherwise, it's going to return the value that we gave it. Completely useless function, but there we have it, right?
Okay.
So that is how we have the partial function, and the compiler will also complain if we don't correctly put that there. You see, like in our terminal down below, function signature is not marked as partial, but the function body can raise an error. So
That's nice. Okay.
needs to be marked as partial. Now, an important part of this is that remember when we talked about previously, we talked about functions and behaviors, right? Functions being synchronous and behaviors being asynchronous, right? Because behaviors are asynchronous, they cannot be partial. This is not allowed.
Okay, that makes sense.
Right? So, and this does have some interesting ramifications that we might get to eventually, but not that super important. Oh, one moment. Okay. We might hear my phone go off a few times. There's only one person who it will make noise for, and that's my that's my wife. So anytime that goes off, that would be her texting me about her trip back from Boston, where she's headed back from. So shall we talk about the recover block?
Yes, let's do.
Okay. So an awful lot of people, when they first start using Pony, they have a hard time with reference capabilities, and they try to consume a lot of variables. Do you remember when we did ISO and consume last time?
Yep.
All right. Yep. And they also try to use recover a lot because they see recover letting them do something like we have here. Okay. We have a mutable string, right? In here called M, which we're taking the name which you sent in and we're appending it to the string hello. Right? It's a mutable string. But then in order to be able to print that string, right? Because printing sends this to another actor, we need it to be immutable. We need it to be a sendable thing of val, right? And what the recover block is doing here is it's allowing us to create this mutable string, but then lift it into being a immutable val. Does that kind of make sense? Or yes, no? If it does, then I'm going to keep going. If not, let's talk about that little bit for a minute.
Yes, that makes sense.
Okay. All right. So this can be safe so long as we follow certain rules, and this is where people generally get tripped up, right? You can create any type of reference capability inside the recover block and do whatever you want to with it. You can only use certain variables which are defined outside of the recover block and still have it be saved. So the only variables that you can reference would be ones which are sendable, right? Things like a val, for example, or a tag that you can set that you would be able to send to another actor.
Okay.
You follow?
Yep.
Okay. And do you understand why then the recover block can be safe from that?
I do, yeah.
Okay.
Because the reference capabilities protect you from all the things.
Yeah, and the only things that we're letting in are things which were already safe to send to something else anyway, which means that we can turn it basically into just about anything we want in that way. So like probably the most common thing that recover blocks are used for is to create a mutable reference like we're doing here with this string, right? And then turn it into into a val, for example. This is probably the most common thing that people would do. And so, if I tried to do something like this, let's do, and, right, so I'm going to create a string reference, right? Oh, oops. Yeah, and is a keyword.
Don't use the keywords.
Yeah, right. A little bit of a Doors thing going on there, right? So if I then wanted to do m dot append e, right, and then I want to compile that, right, I'm going to get the error that we have here, which is that the argument is not the subtype of a parameter, right? See, and you see what it's saying is that do you see this? It's like we're trying to append this string, right?
Yep.
And the argument type is a string tag, right? And the parameter requires a box that is a val or a ref, basically, right? Mm-hmm. And it's true here is that this thing which is mutable from the outside, which is mutable outside. There's a concept called viewpoint adaptation in Pony, right? Which we'll get to eventually. But the basic idea here is it's not like you're completely disallowed from referencing E inside the recover block, but the only thing that's safe to do with it is to use it in a tag fashion, which means that you can't read any fields from it and you can't write any fields, right? You could use it for an identity comparison, basically, but that's about it, right? And that's what this error is telling us, is that, hey, we're trying to use this thing in there, and it's not. But if we had something like this, all right, where it's a val, yay, now it compiles, right? And yes, this is the end, and we're safe there with our recover block and reference capabilities. And an awful lot of people tend to struggle with recover blocks, but that's that's really what it is. It's we can work with non-sendable objects inside of a recover block, not allowing any sendable ones in, and then we can do whatever we want to with it and get a sendable thing back out of it again.
Okay.
Right?
Yep, that makes good sense.
Cool. So yeah, that's everything for step 2. We could move along to step 3 for stuff because we got that pretty good. We
Oh,
ended up covering a
we're
lot
going
of stuff last.
TCP.
Yeah.
Now I'm getting excited.
Oh yes. Here comes the fun. Here comes the fun. Has anybody asked anything in the
Yes, several people are asking questions, but Epic Eric is answering them, and it looks like he's
Yes.
answering them
Uh,
well. So good job, Eric.
yes, Eric is a committer on the pony team. So
Nice. Thank you, Eric.
nice. Thank you very much. Good. Eric, thank you for covering that over there. Awesome. All right. So let's go ahead and let's open up this code, shall we?
Let's do.
Boom. Also, Red vs. Davies, feel free to hit up in the Zulip, and I can try to explain it to you there later. And worst case scenario, we could always hop on a Zoom and we could do that. All right. So let's see. All right, we got the code up here. Yes, we do. All right. I was looking at the live stream at that moment, so the code was way behind, and I forgot. All these windows, man, I get confused easily. All right. So, do you have Telnet on this computer, by the way?
I do.
Awesome. Good. This will make life so much easier.
Oh, maybe I don't. Why would have
No,
known
you
that?
don't.
Is there
Oh,
anything you can do?
Are you on Catalina?
Yeah.
Yeah, they removed it because it's a security problem.
Oh, bless their hearts.
It's okay. Nobody installs Telnet by default anymore.
All right, we're good.
Good. Okay. So, let's see. Let me take a quick peek at what Andy suggests starting with. Right. Okay. That's an excellent point of his. So, let's talk about line 12, shall we? To start with,
Okay.
right? Is, right? The is which is there. So there are traits and there are interfaces in Pony. I believe that we cover these, and a traits are nominally typed and interfaces are structurally typed,
Right.
right? Now, when I declare the is here, the thing that's behind the I'm getting harassed by the cat again. I'm sorry. She really is very needy today. So TCP listen notify, right, is an interface, and when I do is there for this, right? I'm telling the compiler, hey, I'm going to be implementing this interface, and please give me a compile time error should I not be implementing this interface, right? You'll get a compile time error one way or another, but this will make it very clear should you come back in the future. Like let's say that interface added another method, right?
Mm-hmm.
Your code is not going to compile one way or another. But with the is, it's a very nice indicator to yourself with the interface that, hey, this is why it's not compiling, because it's TCP listen notify, and it will then specifically tell you like what method you need to implement in order to meet the interface. And if I didn't have that is there and the interface changed later on, it would tell me that wherever I was trying to use this chat TCP listen notify, that it wasn't of the type that the receiving thing was taking. So there would be a level of indirection there. So for a lot of stuff, people generally tend to do is with interfaces, but that's a personal preference more than anything else. With traits in the nominal typing, because it's nominal, you have to say it is a thing, right?
Okay.
Period.
Yeah.
End story. And at some point, eventually, there will only be interfaces, but they will be called traits. But that's confusing, and let's not really talk about that right now. Right?
Good plan.
So, there's a fairly common pattern in a lot of the Pony standard library for how you implement things. So uh, let's look at it. You see our TCP listener here,
Yep.
right? A TCP listener is an actor, all right, and this actor, which listens for some stuff on TCP, right, accepts a connection and then will do something with it. Has a lot of standard behavior for what you'd want from a listener. The one of the primary things that you supply to it is a notify object, right? This is an object which will get called at certain points in the life cycle. Does that make sense?
It does, yeah.
Right. So our chat notify here, for example, um, uh, if it's not able to actually listen, it's going to do nothing. Okay, right now,
Okay.
right?
Yep.
And if something connects, then what it's going to do is it's going to create a TCP chat connection notify, right? And return that. Okay. And a TCP chat connection notify is another notify, which, if you were to look inside the code for a listener, is when you get a connection that comes in, a TCP listener creates a new TCP connection and needs to provide it with a notify so that you can specialize what's going on in this with your TCP connection. That makes sense?
Yeah, actually, and I like this pattern quite a bit. The actors make so much good sense in listeners like this, whether they're TCP or HTTP or whatever. This is a pretty pattern, at least in my head. You know, it's pleasing to understand this. You pass the TCP listen notify to the listener, and when you get a new connection, it starts this TCP listen notify actor, and then when it starts listening, it runs this listen actor, and then when the listener gets a new connection, it starts the connection notify actor that lets you.
Well, it starts a TCP connection actor, and it supplies it with that notify. It will
Okay.
create.
So these are like
Right.
event type.
Right, because you can see where you have the connected method, right? The
Yes.
connected function on the listener's notify is creating a new instance of the chat notify,
Gotcha.
right?
Okay.
Which will be passed to the new TCP connection one, right? In order to do this. So yeah, it makes it this pattern is very good for setting up stuff for the standard library like this. There are some drawbacks to this pattern, but not something that we need to cover right now. So one thing I want to highlight from these is if you see the constructors here for these, right? We covered this previously, but I want to highlight it again. So this where it says new ISO create, right? This when you call create for this one, it's going to return an ISO instance of this, right? It's not going to be a ref or a val. And by changing the value that's here, right? I change what the default reference capability is for something which is created using this constructor. Do you remember that from before?
Yeah.
Okay, so it's important here that this is an ISO because let's think about this for a moment. For any sort of chat thing or anything that we do, we might want to maintain state for each connection, right? Like somebody could register to say what their username is, and we might want to keep it in their connection, or just where they are in a handshake, you know, if this is a complicated protocol that we're going to implement. And this means that we need to keep state. And if we need to keep state, then we need to have our notify needs to be mutable, and that means it either needs to be a ref or it needs to be an ISO. And it has to be an ISO because it's going to be inside of an actor, and we need to make sure that this data can only be changed by this one actor. That make sense?
It does, yeah.
Cool. All right. So yes, we have our little sucker right there with that. So remember when we talked about capabilities before and we didn't really talk about them very much?
Yeah.
Object capabilities, not reference capabilities, right? Okay, let's talk about what's happening on line 8 here. All right. The TCP listener, it has this env as root ambient auth. What is that? Right? I don't know. Did we? I don't remember. Did we talk about what ambient auth is at all previously?
No, and I'm glad you brought this up because I didn't have a clue.
Okay, so ambient auth is something you're intimately familiar with because all of the programming languages that you use provide you with ambient auth. Ambient auth means ambient authority. Okay, ambient authority means that you have the ability to do anything you want within the program purely because it's in the air. Everything that you might want to do. You can open sockets, right? If you think about it in Go, you don't have to do anything special to be able to open a socket in your program. And if you bring in a library, any library that you bring in can open a socket without having to have any special permissions from the rest of your program or whatnot, right?
Okay.
We're used to that. It's the normal model that we're used to. Um, in capabilities secure languages, um, you have capabilities which are, to be technical for a moment, a unforgeable unique token is the idea, right? And you have to present a token in order to do certain things which we want to control, right? Like, for example, the ability to open a socket. So env root, right, is some capabilities which are provided when the program starts, right? And what we're saying and what we're doing here is we're passing this capability to the TCP listener so that it would be able to do things which require a capability like open the socket. Does that make sense?
It does.
Okay. All right. So in this particular case, and this is for teaching purposes, we're doing something we probably wouldn't want to do, is that we are giving it this capability as ambient authority, which means from ambient authority you can derive any other capability. If I have ambient authority, then I can every other capability is available to me. Anything I want to do can be done from that. So this TCP listener could also open files, etc., anything else. And normally, if you were doing this in like a real program, you'd want to limit the authority that you give it to a minimum. But let's not worry about that right now. All right.
So in theory, I was looking at the standard library documentation, and there,
Yep.
under package net, there is. Hang on, let me go back there. There was TCP auth, there was TCP listen auth, and TCP connect auth. So
Yes.
could we put TCP auth in here
I
instead of
believe.
ambient auth, and
I
maybe it
believe
would
it.
work?
I believe it's actually TCP listen auth, or it could be TCP auth. I don't remember. Let's find out. All right. Um,
Nope.
let's see.
Ambient auth do not match TCP auth. It's TCP auth is not a subtype of ambient auth.
Oh, wait, hold on. Wait, no. Is TCP auth even a thing? I don't
TCP
remember.
auth is a thing. TCP listen auth and TCP connect auth.
All right, hold on. What am I? Wait, let me go to a thing for a moment. All right.
This pattern can never match.
Yes.
Oh, it wants ambient auth or none.
No, hold on. Hold on. I actually have to go look and see
Oh,
what the
we
what the
can't
difference is.
we can't turn root into a TCP listen auth. So
Right. Sorry. I remember what this
that's what
is.
the
Right.
error message is
Yeah.
telling us. So how do we make
Right.
a new one?
Like this.
Oh,
This.
create from ambient off. Okay.
because root is either none or for the time being, every time you start up a pony program, it always has ambient off, right?
Yep.
There's the idea that you would be able to limit this to potentially give no auth to a program.
Yeah, I really like that.
Right.
Oh, did I do that wrong? Yes, I did. I added an extra curly brace or extra parentheses because I thought it was missing, but it's not. Okay. Thank you for answering that, by the way. That
Yes.
auth thing.
There we go.
That's
right.
pretty wicked.
So now the only thing that listener could do is do the TCP listen off, right?
Right.
That's all it can do. Boom, which would certainly work there. Okay, so yes, that is. Yep. And you got another terminal you can telnet into. Yep.
Well, that's just wicked cool.
Yeah. Very, very exciting stuff there, huh?
I can't remember. Oh, there we go.
It's like, isn't it Control D?
I used Control open bracket to get back to the telnet thing. Okay, well that works. Wicked.
All right. So
Because of Boston, I said Boston, and now I'm saying wicked. It's wicked cool.
I say wicked a lot. I say wicked a lot. Yes. So I don't know. Have we ever seen the as keyword before? Going back up to the top here, where we're doing the ambient authority.
No.
Okay. So ambient authority is basically a compiled is saying I want you to treat this as some other type, right? People think of that as casting. You can kind of think of it as casting, but not really. What we have here is that ambient auth, as you saw before, is a union type where it's either a none or ambient auth. Sorry, env root is, right? And so what I'm saying here is treat this as ambient auth. You'll notice that there's a try block around this, right? Because if you do as and the thing can't actually be that thing, right? Or isn't that thing, then it's partial, right? And right. So this is basically so you can do pattern matching as well on the type of a thing, right? And this is sort of shorthand for doing that, where I'm just like, look, if it's not this particular thing, if it's not ambient auth, I just want to stop, right? So it's just going to eat the whole thing up. If that was a none, then we're done. The program would end.
In Go, we would do it with the type assertion. My thing.
Yes.
Dot open parentheses my type.
Yeah, and as is basically the same thing. It's very rare, but you see it every now and then, right?
Cool. Okay.
In the general idea is when you see an as is that you always expect it to be that thing. If it's not, then something's gone horribly awry, right? And in this case, we're not actually handling it, but in general, you'd want to handle it, exit out, whatever that might be. Right. So now let's. This one doesn't look very valuable, right? This not listening. I mean, what's it doing? It just returns none, right? So the thing here with this is that interfaces in Pony can have default implementations. So can traits. All right. This means, for example, that you do not have to provide an implementation for every single one of them, because there'll be some default ones that are there for this, right? Okay. In order to get the default implementation, you have to use is, right?
Okay.
if we remove this is TCP notify, right? TCP listen notify. We try to compile. Right? It doesn't have a closed method, for example. Right? You don't
Okay,
have the
so
closed method, so it's not valid to be there. Now, the reason why we have this not listening on there is that when we were looking at it, I'm actually the one who did the RRC to make this change, was that it would be very easy for people when they're getting started, right? To if there's a default no not listening, then it would fail and they would see absolutely nothing, right? And there would be no idea for it. So we're like, for things which can cause failure on any of the interfaces, which are for handling failures on any of the interfaces in the standard library, they should not be defined so that a user who's doing this has to define this and has to think about what's going to happen in the case of this particular error, right? So for our little example here, it does nothing. But if you were the one actually writing this code, you would have to think, what am I going to do if this can't listen? And if you say, I'm going to do nothing, then if it doesn't work, you're at least, it's not silently happening behind the scenes to you in the standard library, right?
yeah,
Something's not working. Why is it not working? No spooky action at a distance is, one of the things that we'd like to try to avoid. So
that makes sense.
that's,
Good.
and so, if we were to remove not listening, it would also not compile, right? Because that one it's part of the interface. It has no default implementation, right? And you say no body for a method not listening. So we have to put that back. Otherwise, it won't do its thing. Should we talk about what's going on in received for a moment down here in the connection notify?
Well, yes,
All
we
right.
should.
All right. You'll also see it has the same thing with connect failed, right? Because TCP sockets can be two ways, right? It could be, and we have no way of when you're doing a TCP connection of whether this is going to be one that's incoming or outgoing for how the standard library is set up. You have to provide a thing for if the connection was to fail for the outgoing one. But in received, so the important little bit here is that the data that we're getting is an ISO, right? That's coming in for this. So what we have going on here, actually, is let's walk through them. Receive takes three things, of which we're only going to talk about two, because the last one is kind of like uninteresting, and it's there purely for your ability to, if you're writing, try and write stuff which is really fast, or other stuff. So we have a connection, which is a TCP connection ref, right? And we have data, which is an array U8 ISO. All right. So we generally don't see stuff with a ref all that often. The TCP connection ref. So this is a reference to the TCP actor, TCP connection actor that this notify is running inside of, right? And would allow you to call methods on that actor in order to change the state of the actor potentially, right?
Yep.
Things that could change the state of the actor, like, for example, write, because writing on that connection will change the state of the actor. It's going to put some stuff into a pending queue, and then the stuff will get sent out on the pending queue, right? So this is a common part of the notify pattern. Inside an actor, which from the outside world, everybody sees it as tag, internally it sees itself as ref because it can mutate all of its stuff. It's a nice, safe, mutable place in there. And so to any class which is part of the actor, which is part of its fields, you can supply a reference to yourself, a ref reference. I got to find a better way to say that, which would allow you to do stuff like this. Right? Does that make sense?
Yes.
Okay.
Redford
Then
Davies asks if we're using an array of U8, does that mean we have issues with Unicode? Is there assumption that one U8 is one character?
No, there's an assumption that one U8 is one U8. That if you were to send Unicode, then that is going to be more than one U8. Now, if you want to turn that into a string, then you can run into assumptions, right?
Okay.
Um,
So we're just
so
taking a string of or a stream of bytes, and we're consuming them, but we're not necessarily treating them as if they were anything other than bytes.
yes, it's purely bytes, and whatever the thing which is receiving those bytes and putting them out to a screen or a file or whatever, however it wants to interpret them is how they will be interpreted in this particular case. Right?
Okay, is there, in jumping ahead of the game, is there something in the strings package that you can use to, how would you take those bytes and turn them into a string?
So yes, the default assumption is that you're using that it's sorry, yeah, in the strings package. But let me go ahead and let me go to the standard library docs for a minute, right? Bum 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 bum. In the built-ins, because that's a built-in. Right. So there's string bytes and string runes, right? And in this particular case, if we want to work with that, it would be runes. And the runes class takes a string, right? And you can then interpret it based on different encodings.
Beautiful. Okay, that's all we need. We don't need to go too far off track there.
Yeah, I will say that the support for strings could be way better. All of this. Joe put together an RFC, or he was gonna put together an RFC. Joe being one of the core team members, to have it be much more Elixir-like in how stuff is done. So it could certainly be nicer. And in the end, handling Unicode type stuff is not the greatest thing in the world. In Pony stuff, and there's probably going to be some pain points for anybody who's working with that. If you can treat it just purely as bytes, which an awful lot of applications can, then life is wonderful and happy.
Perfect.
Yep. So, and the important, the biggest, most important part of this is if you look on line 45, we have to consume this data, right? This data is the data that we've read off the socket so far. Right? It was read off. It was given to us, and it's an ISO so that we can mutate it or do anything that we want to with it, which means that if we want to write it, for example, we have to consume it and give up our reference to it. Make sense?
Mm-hmm.
And without that consume, oh no, we're going to get a compilation error, right? Yep. See? The ISO bang, that means like it's an alias to it, right? If you remember before, aliasing, passing something to a method is aliasing it. And so, nope, we cannot do that. It will not let us do that. There we go, consume, and we're all good for that, right?
Yeah, except that error message, I would spend 3 weeks trying to figure that out. Argument type is an array of U8 val. Parameter type is a string val or an array of U8 val. Array U8 val ISO is not a subtype of string val. ISO is not a subtype of U8 string val. ISO is not a subcap of val. So
the argument is not a subtype of the parameter, right? The argument type, the thing that you missed off the end is this. This is part of the type. The bang. It's ISO bang. It's not ISO. It's ISO bang.
Okay.
Bang means that this thing has been aliased. Right? This ISO has been aliased. This is a alias to an ISO. Not an ISO, but an alias to an ISO.
Yeah. I can see myself hanging out in Zulip on this one, but that's okay.
Yeah, and so if you go to the Pony Lane website in the Learning Pony section,
Hmm.
there's a whole bunch of materials around learning reference capabilities, and in particular, there's a blog post from a few years ago called "Bang Hat and Arrow in Pony," I believe is the name of it. It's by Chris Double, and it explains everything that's going on with Bang here and with a couple other things that people would tend to see, which can trip them up, right? But here would be a rule of thumb for you, okay? Anytime you see a thing saying, "Hey, this thing is an ISO Bang," right, and it's giving you an error message, consume the thing, consume it. In
Okay,
all likelihood, that's your problem. Is you forgot to put consume, right?
that makes good sense.
Indeed, indeed. All right, all
Buffering to
right.
ask the received callback appears to be when a control line feed was sent by the client. I'm guessing that the buffering was done by something. I think, yeah, that's
There
done by
is there.
the telnet client. You can
Yes,
send
there.
control M instead of sending.
Yeah, there is no buffering in the Pony stuff for this. If you look at the TCP connection class, the TCP connection actor, there's a method called expect, which will cause the actor itself to do buffering, so that you can do like framed protocols, right? So if I call like here, let's write some code, shall we? While we're
Yes,
here
let's.
talking about this. Okay, so that's on fun ref. Let me take a look at the code for the next thing real quick before I go writing all of this to see if we're going to end up using that anywhere or otherwise. No. Okay. Good. All right. So it is connected, right? When we are connected, we have a con TCP connection ref. Okay. Um, Actually, we don't really need to do that for this one. Okay. So what we're going to do is we're going to have a variable that we set. All right. Call it expect. So U64 equals 4. And actually, yeah, no, we do need to do that. Fun ref connected, con TCP connection ref, con expect. Okay.
So this
With
is
this,
saying I want four U64 bytes.
I
Four
want 4 bytes.
U64s. Yeah.
So 4 bytes, and we're never actually even going to change it. I didn't even need this thing up here. Let's get rid of that. We'll just say it's 4 every time. All right.
Okay.
So if we do Pony C, what did I do wrong? Oh,
An error can be raised here.
right. Yes. Sorry. Yes.
Wait. Let me
That.
do it. I want to
Okay.
do it. What am I doing up on top? Try end. Just an end.
Mm-hmm.
Okay.
Mm-hmm.
Did I do it? Let's find out.
Mm-hmm. Let's find out.
No.
Oh,
F does not implement its provides list. Partial function is not a subtype of a total function.
right. Because see, what it was telling you, was, hey, this is supposed to be total, but it was partial, right?
Call is partial, but the method is dash. A question mark is required after this call. Oh, see, these kind of error messages I can get behind.
There you go. Okay, so let's run this and then telnet and send like a I don't know, like Brian as a name would be good, you know? in your other terminal. Did we do something? Wait, expect for.
Well, we didn't really tell it what to do after.
Sorry. No. Oops. No, I did the wrong method. It shouldn't be connected. Hold on. I'm going to go look at the notify for a moment and remember what that is. That's the wrong method. TCP connection notify. Right. Change that connected to accepted. And then let's do this again. Yep. So connected is when you successfully complete an outgoing connection. Right? Accepted is when an incoming connection starts for this.
And it took the 4 bytes.
You took the 4 bytes. Now send some more bytes. Right? There's your N.
The N,
right?
And the A, and the S, and the D. All right, so it's grabbing 4-byte frames each time.
So it got the N, it got the new line in the A, right, and some stuff there, and so yeah, it's just grabbing 4 bytes at a time, and received will be called each time with 4 bytes in this particular case.
All right, so let's do one more thing, and then I'm probably going to have to call this a day. Let's pretend that we were writing a parser, and we had multiple different frame sizes. So let's do let.
You're gonna want a var. You're gonna end up changing this. Yeah.
Oh, you're right. And that we'll just make that a U8 or something small, right?
Okay.
And then we expect to see the first time, like step 0. If does this need to be in parentheses?
Well, I don't know what you're doing yet.
Okay, so I just want to say if the step. Let's default it to 8 or to 0.
Okay.
I'm sorry.
Okay.
Like that.
Yep. Okay.
Right, so if we're on step 0, if step. My microphone's in the way of my keyboard.
Okay, so I don't think you don't want this in accepted because it's always gonna be 0. You probably want this in received, whatever it is that you're doing.
Yeah. I think you're right.
Just remove the step line, just line 51, and then. Oh. Okay, let's see where you're going with this. Okay.
All right, so if the step is 0, we want 4 bytes. Otherwise.
Okay, so for that you'd want to do here. Let me show you one thing that's slightly different because that's not going to work, right? You want this. So step 0 is the first time is going to be also the first time it runs, right?
Oh, okay.
So you already need to have said, right?
Take the first 4 bytes.
Take the first 4 bytes, right. Before we start reading, right? Yes.
And then we'll set the step to 1.
Yep, we can do that too.
Is there a switch statement or pattern matching or something I can do up here on the steps to make it?
There is pattern matching. There is pattern matching, but we'll just do the if and else if.
Okay.
Right now, that's fine.
So we want. Let's just say we want 4 bytes, then 2 bytes, and then
Mm-hmm.
10. I don't know.
Okay.
Who knows what this is?
All right.
If step equals 1, expect 2.
Mm-hmm.
Expect 10.
Mm-hmm.
And then we need to consume con dot, what was it, right?
Mm-hmm. Consume data, and that'll send it back. Yes. So the one thing you need to, you're not incrementing your step right
Thank you.
now,
Good call.
right?
Should you do that inside or outside the try?
Well, I think the more important thing here is if you do it before you get to the 48, it's going to change it from 2 to 10 on you, right? So maybe like this, all
Else?
right? Yeah. Right. More like, hey, I see what you were talking about for the pattern match now, right?
Yep.
Yeah. So we could do that, but let's just go ahead,
It's
go
okay.
for
We can
this.
do it with a if.
I'm now going to tell you a thing, okay? It doesn't matter what programming language I use. I cannot remember whether it's elif, elsif as one word or elsif as two words, including pony.
Yeah,
All right.
that's
So
fair.
we're gonna find out what elsif is, because for the life of me, I can never remember from one language to another. There are certain blocks that people obviously have in their head. That's one for me. So yeah, we could do this and then just do like, yeah. Right?
Okay. So
Nice.
if I need a then here.
Oh, yeah.
Apparently then is important. Unterminated if expression. So I've got a try and end,
Oh,
else.
I'm not even, because you switched to a different terminal and it didn't switch for me.
Oh,
Right.
sorry.
If expression, if this, else, try, end. Well, that's
42.
got to be. Because in pony, it's else if as one word. There we go. That's like I said. I do not remember from one language to another.
Oh, that's better. Okay, so 4, then 2, then 10. So I should take 4, 2.
Oh, you got a problem here. Yeah, it did exactly what we told it to do instead of what we wanted it to do.
They always do. Oh, I do have a problem, don't I?
And that's
Yep.
not C.
Yep.
I've been working with a lot of C the last few days, so I tend to put a lot of semicolons on the end of my pony code.
Yes! Look how smart we are.
Yep. It helps to put the new line. The first time when it did it, I was like, why didn't you? Oh, right, new
Oh,
line.
yeah. Because we're
New line.
just writing
Yeah.
bytes to the stream. This is
So
awesome.
So if you're doing a frame TCP protocol, like that's why expect was put in, so that, you can be something like, I have a 4-byte header for all of my messages, and the 4-byte header is going to tell me what the payload length is
What's
of
my
what
message type?
yeah, how big is it? How much should I read for the next one? And you can do that. And at one point in time, like probably a year and a half ago or so, that implementation was pretty slow-ish comparatively, because it was doing a read call to the operating system every single time, right? And once all the Heartbleed stuff came out, that was like a real impetus to, hey, we need to cut down on system calls. So underneath, I wrote some stuff where it allocates a big ass buffer and reads as much of it as it can in off the socket at one time, right? And will then just start handing it out to you piecemeal based on your expect value. And when it runs out and you're wanting and you need more, it'll go ahead and it'll try to read more data into the buffer again, etc.
Makes sense. This is epic. Love it. I'm still
Cool.
iffy on
What are you iffy on?
reference types, but that's okay. Well,
Well,
I think that's just a thing that I need to play with more.
it takes a while, right? But you're doing pretty good there. If when you're doing stuff inside of an actor, it's usually not that difficult. I tend to like to get people started with simple TCP stuff like this because you don't have a bunch of actors communicating with one another. You're not having to worry as much about the reference capabilities. There's a bit there, but not too much. Like the only thing you really need to worry about for the most part here, probably unless you start trying to do something really sophisticated, is the consume that you need to do, right? Because it's mostly it's like, hey, you've created a couple classes that are running inside of an actor, and everything will be pretty much swell with that. So I would say next time there is step 4, right? Which we could work on
Chat
step
server.
4. Yes, which is the
Nice.
beginning of the chat server, and that's it's the last exercise in the workshop because it's like, well, let's just keep adding features to the chat server, right? And we can start figuring out how to add different features that we might want to add to the chat server.
Awesome. This is really cool. Maybe next time we'll run this up in the cloud and let everybody else chat with us.
Oh, oh,
And play along at home, kids.
oh! That sounds like fun. That sounds like fun.
Excited.
Danger, though. Danger. Accepting input from people all across the.
Random people. I think we just pipe it to exec and bash, and we should be fine.
Oh, I love. I just checked out the chat just now. I'm glad to see that Eric also has the same issue with remembering what LSEF is in different languages and just keeps going till the syntax highlighter. Do you remember? Oh, you keep going.
I was just going to say the switch statement in all of the C derivatives it's the same.
Like this is something I don't think it made it the previous video, but we were talking about it when we were trying to get the audio set up for the first one, right? When I was telling you, oh, your theme is very different from mine. Mine is basically just black and white with keyword highlighting, right? Mm-hmm. Yes, I want the keyword highlighting so that it can help me remember like else if and things like that. And for things like, oh, I just tried to name a variable end, but it's in bold. Thank you. That's a keyword, right? So yes, that's why I don't just have straight plain text for my theme.
Perfect. All right. Well, thank you again for masterclass in Pony. Thanks to everyone listening and watching for putting up with my audio difficulties. I'm done with this whole audio thing.
But maybe next time it'll be easy. Don't change any of the components like you did between 1 and 2.
Good plan.
Good plan. I don't even know what was different. I don't remember.
Actually, everything was different, but that's okay. All right. Thanks, Sean.
All right. I'll talk to you later.